Okay, so this next section, 8.4 and 8.5, we're moving on to specific types of similarity. So we've done similar figures. We've looked at all kinds of different shapes that can be similar. And then we talked about similarity transformations, which are like your dilations or your translation, rotation, and reflections. So now we're going to work specifically with triangles. All right, so previously, to determine whether two figures were similar, we checked that all angles were congruent and all sides were proportional, right? We set up those ratios and checked to see that they were the same, okay? But there's an easier way to determine whether two triangles are similar. Okay, and there's three different similarity statements that we use. The first one is angle-angle similarity, which pretty much says that if two angles in one triangle are congruent to two angles in another triangle, then those two angles are similar. Okay. So in this picture here, I'm actually going to thin my pen here. We have angle R over here is the same as angle V. Okay. But also, and we don't know anything about angles W and B, but we do know something about these two in the middle, right? These two triangles are nose to nose. Okay. So we created a pair of vertical angles when we set them up like this. So angle S is shared by both of these triangles, which means that angle S is congruent to angle S. So this is why we have angle, angle. I'm going to abbreviate this. Angle, angle, if I can do it, similarity. And we use that little similar symbol. Okay. So what does angle, angle similarity say? If two angles in a triangle are congruent to two angles in another, those triangles are similar. Okay, and this is angle-angle similarity. The next type of similarity is side-angle-side similarity. So side-angle-side similarity says that if you have two sets of corresponding sides that are proportional, and the included angle or the angle in between them in each is congruent, then your two triangles are similar. So let me write that out. I'm going to use a different color here. Okay, so if two sets of corresponding sides, which means matching sides. Whoa, that doesn't look like a D. Are proportional. And the included angle, which means the angle in between your two sides, are congruent. Actually, I'll use the congruent symbol there. Then those triangles are similar. And we call this side angle side similarity, or SAS similarity. So in this picture is a little bit confusing. We have an overlapping here, and they tell us that the distance of this side right here of our smaller triangle is 8. And then the distance from K to point M is 8 plus 2, which is 10. And then on this side we have 12. And then from K to N, we have 12 plus 3, which is 15. So we want to check and see, are these ratios the same? So we have 8 to 10 equals 12 to 15. So 8 simplified, or 8/10 simplified is 4/5. And 12 to 15 simplify is 4/5. So these sides are proportional. And then the included angle in this picture, it's angle K. That's the angle that's in between these two sides. Well, since these pictures are overlapping each other, we just need to see, does angle K match angle K? And it does. So this would have side angle side similarity. Okay. The last one we talk about is side 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 similarity. Side 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 similarity says that if all three pairs of corresponding sides are proportional, then your triangles are similar. Remember, similar does not mean congruent. Similar means they're the same shape, but different sizes. Okay. This is side, side, side similarity. So in order to check this, we want to check all of our ratios. We want to see if our matching pairs, so 10 to 15, 6 and 9, and then 8 and 12, if those are all the same ratios. So we have 10 to 15, 6 to 9, I'm going to run out of room here, 8 to 12. We want to see, do they all simplify to be the same thing? Well, if I divide 10 and 15 by 5, I get 2/3. 6 and 9 divide by 3 is 2/3. And 8 and 12 divide by 4 is 2/3. So these are all the same ratio. We have side, side, side similarity, which means we don't have to check the angles as well. If we check all three sides and those are good, then we don't have to check the angles, so they're similar. On our side angle side similarity, if we check two ratios and the angle in between them is the same, then we don't have to check all the other angles or the other side. And then angle angle similarity says if two of those angles are the same, we don't have to check the sides. We don't have to check the last angle either. Okay. So we can use these three theorems, or these three similarity statements, to prove that triangles are similar with a lot less work than all of the other shapes. So in these examples, we want to determine whether these triangles are similar, and if they are, we're going to write a similarity statement and name which of the theorems from up above we used. Okay. So this first one, we have that this bigger triangle, we know that this pair of sides and this pair of sides are the same. And in my smaller triangle, I know that this side and this side are the same. I know that this angle is 68 and this one is 62. I don't know if two angles are the same because I have 68 and 62, so I can't use angle-angle similarity. And I don't really know much about my sides compared to each other because they didn't give me any distances. Okay. So if I wanted to see if two of my angles were the same, these are both isosceles triangles, which means if this top angle up here is 68, this one is 68. So I could figure out what this last one is by doing 180 minus 68 minus 68. Okay. Since this one up here is 62, these two have to be the same. Okay, which means that they are both 59. So that doesn't really help us much. Okay, none of our angles match up and none of our sides are proportional because we don't know the ratios. Okay, so we know for sure that these are not similar because no angles are congruent and we need all of them to be congruent. Okay. In number 2, we have a matching angle and we have two sides on either side of our angles. So I'm not going to be able to use angle-angle similarity here, and I probably won't be able to use side-side-side similarity because I don't know all three sides. But I'm going to check and see if side-angle-side similarity works here. So what I need to check is if the angle in between those two sides is the same, which it is. We have 70 and 70. So that's the first thing. Next, I want to check my ratios. So side 16 here is a matching pair for side 20. And then side 12 is a matching pair for side 15. So I want to create that ratio 16 to 20 and see if it's the same as the ratio 12 to 15. 16 and 20 can be divided by 4, and we end up with 4/5. 12 and 15 can be divided by 3, and we end up with 4/5. So we have two pairs of proportional sides and one angle in between them. So yes, these are similar by side, angle, side similarity. And so how do I write the similarity statement? I would say triangle. It doesn't really matter what order the first one goes in. AUG is similar to triangle. I do want to match my angles up here though. Angle A and angle B are the same. Angle U and angle F are the same. And then G and E. Okay. So I have my ratio of my sides is the same, and I know that angle G is the same as angle E. So here's my final answer. Okay. Let's look at number 3. Number 3, I don't have any angles, so I know I'm not using side, angle, side, or angle, angle. I want to check for side, side, side. See if my ratios are the same for all 3 pairs of sides. So I need to match my sides. Because I don't have any angles, what you really want to look for is your biggest side goes to your biggest side, your smallest side goes to your smallest side, and then the middle one goes to the middle one. So my biggest side here is 60. The biggest side here is 40. Then I have my smallest side is 22. My smallest side is 32. And then 30 and 45 are the middle. So now I want to write my ratios. We have 60 to 40. I want to see, is that going to end up being the same as 45 to 30 and 32 to 22? Well, divide 60 and 40, I can divide those both by 20, and I end up with 3/2. 45 and 30, I can divide them both by 15, and I get 3/2. And then 32 and 22, I can divide them both by 2, and when I do that, I end up with 16 over 11. And that's, sorry, there's the bell. That's the smallest I can make that fraction. So these are not the same. So these are not all proportionate, which means that these shapes are not similar. Even though I don't know anything about my angles, they're not similar because all sides are not proportionate. Okay. Last one for this page, before we move on to some more examples. We have number 4 here. This is, like I said, a really common one. If you were in my class, I said overlapping pictures is really popular. They put the smaller one on top of the bigger one. Okay. And when they do that, they're going to make you figure out how long the bigger side is. They give you each piece is 6 and 6, so this big side is 12. From here to here, each piece is 8, so this big side is 16. Okay. I only know 2 sides, and I do know one angle. Angle A is 90 degrees, and that's the one that's in between both of our sides. So angle A is congruent to angle A. That checks off my included angles the same. Okay, so now I need to check my sides. My smaller side here, 6, is paired with the bigger side, 12. This smaller side, 8, is paired with the bigger side, 16. So my ratios, I have 6 to 12 and 8 to 16. So that's 1/2 and 1/2. So my sides are proportional. My included angle is the same. So yes, these are similar. By side, angle, side, similarity. And my similarity statement says that triangle, and that first triangle, it doesn't matter what order you put the letters. I can do ALW is similar to triangle. Now I want to match my angles. A is the same as A. L is the same as C. And W is the same as E. And that's my final answer. Okay. Now let's look at some more examples. Still checking similarity statements. Okay. On number 5 here, this is that same bow tie problem in our last section. Okay, we have these vertical angles here, which means those are congruent. But then I don't know much more of my information because they didn't give me any numbers. But what they did show me is that this side right here is parallel to this side. And whenever we have parallel lines, we're creating alternate interior angles, alternate exterior angles, corresponding angles, all that kind of stuff. So in this picture, that means that this angle and this angle, angle F and angle K, are congruent because they are alternate interior angles. Angle F and angle K are congruent because they're alternate interior angles. So, are these similar? I know 2 sets of angles are congruent. So yes, these are similar by angle similarity. So my similarity statement would be in triangle. This first one, it doesn't matter the order. FGH is similar to triangle. Now I want to match KJH. And there's our answer. Now number 6, we don't have vertical angles. It looks like maybe angle K is going to create vertical angles, but remember, they need to be exactly straight across from each other. So we don't have 2 angles. We only know one angle, and it's this right angle. And then we have some sides. So I know 16 has a matching pair with 9. Sorry, guys. I I'm getting ahead of myself. Okay. So remember how I told you to pair biggest to biggest, smallest to smallest? That's what we want to do here. That 16 and this little triangle right here, it's kind of flipped on its side. So I want to take it and turn it, and it would be 16 to 12. And then I would have 12 and 9. So it's almost like this smaller triangle is laying on its side. So then I'm going to check the ratios. So 16 to 12, 12 to 9. 16 to 12, if I divide them both by 4, I get 4/3. If I divide both of these by 3, I get 4/3. So my ratios are the same. And my two angles, I have angle N is the same as angle G. So we're ending up with, yes, these are similar by side, angle, side, similarity. And my similarity statement is triangle PNK is similar to triangle. The angle that's similar to or congruent to P is angle K down here. Okay, and then NG, and then K here is D over here. And that's our final answer. Okay. Try number 7 on your own. See if all of those sides are proportional. And then come back and check and see. So longest to longest. We have 9 to 12. And then I'm only going to write this once because they're both the same. 6 to 8. So 9 to 12, if I divide them both by 3, we get 3/4. Divide these both by 2, I get 3/4. Okay, all of the sides are proportional. So yes, these are similar by side, 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 similarity. And my similarity statement, triangle ABC, is similar to triangle. And how do I match my angles here? Well, I want to match the corners of my colors pretty much. So angle A is between the green and the blue. So that's angle E on my other triangle. B is between blue and yellow, F, and then G. Okay. Number 8, we don't have any sides. So I know I'm not doing side, angle, side, and I know I'm not doing side, side, side. So I'm really just checking for angle, angle. Okay, so I know that all the angles they gave me, none of them are the same. But we do know that this one in the middle is the same as the other side because they are vertical angles, right? But that doesn't tell me anything about the other angles, so I need 2 congruent pairs, and I only have 1 congruent pair. So these are not similar. Because not all angles are congruent. Number 9, I would be checking side, 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 right? Because I don't know any angles. So match up my sides here. We have biggest to biggest, smallest to smallest, and then our middles. So I'm checking 2 to 3, which that's the smallest that fraction is going to get. So I don't need to keep changing that or simplifying that one. 4 to 6, which is, if I divide them both by 2, it's 2 to 3. And then 3 to 4.5. Okay, I want to see, is this really the same as 2/3? And if I get this as a decimal, if I get all of these as a decimal, I'm getting 0.6 repeating. So yeah, these are all the same. 0.66, 0.66, 0.66. So are these similar? Yes. By side, side, side similarity. And my statement, similarity statement, triangle ABC is similar to triangle, well, A is between green and yellow, so that's F. B is between blue and green, E. And then D is between, or C is between blue and yellow, which is D. Hey, last one I'm checking. So again, we're given some parallel lines that might be important to us, right? I know that there's an overlapping picture here. We have this smaller triangle sitting on top of this bigger one, but they have one angle in common. That's angle M. So we know angle M is the same as angle M. Okay. They don't give me any sides, so I can't check for side, 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 or side, angle, side, but I can see if there's angle, angle similarity. So with these parallel lines, we're remembering that we can create alternate interior angles, corresponding angles, alternate exterior, consecutive interior, all of those. So let's look at angle L and angle S. Those would be considered corresponding angles. And because those lines are parallel, because of those two little arrows, these would be congruent. Same with T and N. So I know for sure that these are similar figures because of angle, angle similarity. And my similarity statement, triangle, again, it doesn't really matter the order of your first one. Let's do SMT is similar to triangle LMN. Okay. Moving on to our last little group of 4, we're going to find the distances of our missing sides or variables using those similarity statement or similarity theorems from above. Okay, so in these examples, we have similar figures. So we know the properties of similar figures. Okay, so in 11, we want to find the distance represented by x, or this missing triangle side here. Well, that corresponds to this side over here. We know that this side corresponds, hang on, to this one. Okay, and we can be positive that these are similar because this is side angle side similarity. Okay, so we have two sides with an angle included in between them. So my proportion, if I'm finding a distance, I'm creating that proportion from our last section. 90 goes with 135, and that equals 120 over x. We can cross multiply here. 90x equals 120 times 135. 120 times, whoa. Hold, guys, my calculator's not pulling up. There it is. So 120 times 135, 16,200. But that's okay. It's really big. We're gonna make it smaller when we divide by 90. We get 180. Okay, and this is feet. On number 12, these figures are not the exact same thing. We have, I think that's a cat and a tree. Okay, but they're creating similar shapes with their bodies, right? With the tree and the cat, we're creating this kind of triangular shape here. Okay. So the distance between the corner here and the cat is 0.3 meters, and the height of the cat is 0.45. The distance from this corner here to the tree is 2.2 meters, and the height is what we're trying to find, that HM. Okay. So we're going to set up our ratio. 0.3 meters is the distance from the corner to the cat. So that goes with our 2.2 meter. And then the height is 0.45 meters to H, what we're trying to find. So we can cross multiply. 0.3 times H, 0.45 times 2.2. Divide by 0.3. 0.3. So H is 3.3 meters. Did I do that? Hang on, I want to double check my math. Yes, we're good. Now number 13, we have side, side, side similarity here. Because all of our sides are going to be proportional. We only know our sides. So I want to set up some ratios here. It doesn't really matter too much the way you set these up because all of your sides are congruent. So I can do 10 and 2x. I can do 10 like this. So I have 10x minus 10 to 4. It's 10. Actually, I don't want to do it that way. I want to split up those variables there. Sorry, guys. So we have 10x minus 10 to 2x equals 10 to 4. Cross multiply. We have 4 times 10x minus 10 equals 10 times 2x. Simplify, we have 40x minus 40 is 20x. Get all of our x's on one side. And then divide by negative 20. So we end up with 2 equals x. Okay. On number 14, we have another set of parallel lines. So we know that this angle and this angle the same, this one and this one are the same. This is congruent to itself. So this is angle-angle similarity. So I want to create some proportions for my sides. So my smaller triangle here, I have 6 and x minus 1. And then my bigger triangle, this side, is 6 plus x and 2x plus 4. So my ratios, I want 6 goes to 6 plus x, and x minus 1 goes to 2x plus 4. Cross multiply. I think I put 6 plus 6. I didn't mean, I want 6 plus x here. Okay, so I end up with 12x plus 24 equals, now this is going to give me a quadratic. Okay, when I multiply this out, I'm going to end up with x squared plus 5x minus 6. Now, because I have a quadratic, I need to get this equal to 0. So I'm going to subtract 12x from both sides. And then subtract 24 from both sides. So we end up with 0 equals x squared minus 7x minus 30. Okay. The reason I wanted it equal to 0 is because to solve a quadratic, I need to make sure it equals 0 first. Now from here, you can do a couple of things. You can factor this, you can graph this, you can use the quadratic formula. I'm just going to tell us our two answers. We end up with x equals -3 and x equals 10. But this answer right here doesn't make any sense because we're talking about distance. We can't have it be negative. So we get x equals 10. Okay, and I don't think I wrote on number 12 what similarity statement we use here. We are creating right angles here. And then with our sides being proportional, we know that those angles are the same. So this is angle similarity. Or, because we know our sides are proportional, side angle side. Okay, so we're going to be using these similarity theorems with triangles for a little bit longer. We're going to talk about them. Okay, let your teacher know if you have any questions, and they will be able to help you out. Thanks.